Now we discuss about the indefinite integral part 3. In the first part, we discuss about the methods of integration. Generally, we use statement. That is, one is your integration by substitution, and other one is integration using partial fraction. Now, the third method is generally it's the most important one. That is your integration by parts. And this third method in this particular topic, part 3, is your integration by parts. This particular topic is based on an important product of two functions, and this product of two functions is represented as f1x into f2x. Dx is equal to f1x integration of f2x dx minus that's whole integration, and this is d by dx f1x and integration of f2x dx again and whole integration of that figure integration form. Here there are two functions f1x and f2x, maybe in algebraic, trigonometric, exponential, logarithmic, and the first function we have to select in such a way that we only differentiate one of the function, and the other function we have to take in as the integration, and that integration twice, and we solve the question in such a way that our process of integration is finished and we get the required answer. Now in this question, we have the selection of the functions f1x and f2x is most important. Let us try these questions like this. That's example. That example we are taken, suppose integrate x sin x d with respect to x. Here there are two functions, x and sin x. Let I is equal to integration of x into sin of x dx. This the x function we differentiate and it becomes 1. And this sin x integration is minus cos x, and cos x integration is sin x. And similarly, if we choose the first function as sin x, then the differentiation of sin x is cos x, and differentiation of cos x is minus sin x, means it's just a rolling system. We just convert sin x into cos x and cos x into sin x. So best way that in the differentiation we have to select in such a way that our process is stopped and we get the required answer. And for this I am taken here f1x is equal to x and f2x is equal to sin x. Here I have to taken x integration of sin x dx minus this whole big integration sign, and this is in the bracket d by dx f1x or simply x, and integration of sin x dx, and this is like this. This is the integration with respect to x, that dx is the bigger sign and this one is the smaller sign dx. This is equal to, as we know that the integration of sin x dx is equal to minus cos x, and integration, so therefore minus x cos of x minus integration of this d by dx always equal to 1, and this is equal to minus cos of x dx. This sin x dx is now merged in minus cos x, and this dx is coming. And it's very simple, dx upon dx is equal to 1, and this is equal to minus x cos of x plus, and this is your cos of x dx. Why? Because this cos of x and this minus and that minus x cos of x plus sine of x, and our integration process is over. We are just an initial stage of this integration, and therefore indefinite integration, and that's why we used a C, where C is integrating constant. Now taken a function, integrate. This is my formula, and this is example number 2. We can say that integrate, that is equal to e to the power x cos of x with respect to x. Here I select this question because the differentiation of e to the power x is e to the power x. Integration e to the power x is also e to the power x. Differentiation of cos x is minus sin x, and integration cos of x is equal to sin x. So in that case, let I is equal to integration of e to the power x cos of x dx. Here in this case, I am select any function is f1x and f2x. So I am second, suppose f1x is equal to e to the power x and f2x is equal to cos of x. So this f1x is equal to e to the power x and f2x is equal to e to the power cos of x. This is my equation number 1. I am using this equation after some time later. Now this is equal to, the first function is e to the power x and integration of cos of x dx minus the whole big integration form, that is equal to d by dx e to the power x integration of cos of x dx, and this big integration sign dx is separate from this big bracket. Now what is the integration of cos of x? Integration of cos of x is equal to sin x, and therefore we can say here this is equal to e to the power x sin x, and minus integration of e to the power x sin of x dx. This integration cos x is become sin x, and this dx. Now again we have to apply the same form. f1x is equal to e to the power x, and here the thing is e to the power x sin of x minus, now I am integrate this e to the power x sin x. Here I am taken f1x is equal to e to the power x and f2x is equal to sin of x. Now this is e to the power x integration of sin of x dx minus big integration sign differentiation of e to the power x integration of sin of x dx, and this is again dx. Now this is the first term is as it is, and this is written as e to the power x sin of x minus e to the power x, the integration of cos of x sin of x is equal to minus sin x, cos x, and therefore it is written as minus cos of x, and this is minus integration of this e to the power x, and this is written as again e to the power x, and this is minus cos of x dx. This is equal to e to the power x sin of x minus minus plus. This minus and this minus becomes plus, and this will be plus e to the power x cos of x minus e to the power x. This minus is multiplied with this minus because this is my brick bracket. This minus and this minus plus, and this minus is again becomes minus, and therefore it is e to the power x dx. Again I explain this one. This minus and this minus become plus, and this plus is multiplied with this minus. It is minus. Now what is this? This is nothing but this first equation, and therefore this I is equal to e to the power x sin of x plus e to the power x cos of x minus I, and this I is coming here, so 2I is equal to e to the power x. In the bracket we can take sin x plus cos of x plus c, and if you wish you can proceed further, then I is equal to 1 by 2 e to the power x sine of x plus cos of x and plus c, and this complete whole bracket, and this is my required answer. So this is the most important question, lot of time asked in the examination also. So okay, wish all the best for the future. Okay, goodbye.